Alright, here we go. Today we are going to be discussing a little more about how to prove if lines are parallel. You will be able to use the converse of the corresponding angles theorem, prove theorems about parallel lines, use the transitive property of parallel lines, and apply these theorems to solve problems. Take a moment, pause the video, go over the objectives and vocabulary, then gear up. Let's take a dive. Okay, last time we learned about the theorems, the corresponding angles theorems, the alternate interior angles theorem, the same side interior angle theorem, and the alternate exterior angles theorem. This time we're going to learn about its converses. So we're going to take the converse of each theorem and then prove that lines are parallel. Before, the theorem said, for example, in the corresponding angles theorem, that if two lines that are parallel are cut by a transversal, then the corresponding angles were congruent. That's, for example, corresponding angles will be angles 2 and 6, angles 1 and 5, 4 and 8, in this case I'm talking, and 3 and 7. Those are corresponding angles, and if the two lines were parallel, then those corresponding angles would be congruent. Well, in this case we're going to say the converse of that. If two lines and a transversal form corresponding angles that are congruent, then the lines are parallel. Before we were saying that if the lines were parallel, then the two corresponding angles were congruent. So take a moment and copy this down. You could feel free to pause the video. We have the converse of the alternate interior angles theorems that says that if two lines and a transversal form alternate interior angles that are congruent, then the two lines are parallel. We also have the converse of the same side interior angles theorem. This is also called the consecutive interior angles theorem. If two lines and a transversal form consecutive interior angles that are supplementary, then the two lines are parallel. Remember, supplementary means that they add up to 180 degrees. Then we have the converse of the alternate exterior angles theorem, that if two lines and a transversal form alternate exterior angles that are congruent, then the two lines are parallel. Let's take a look at how can we use these to solve a little problems. For example, which lines are parallel if and why if angle 1 is congruent to angle 2? In this case, what they're saying is that angles 1 right here is congruent to angle 2. Notice that these two angles right here, if we take lines C and D and then let line B be the transversal, then these would be corresponding angles. Okay, so basically what we are going to say to answer this question is that lines, let me grab my pen, that lines C and D are the parallel lines. Okay, so as line C is parallel to line D. Write that, line C would be parallel to line D. The transversal will be lines B, right? Why? Because the converse of the corresponding angles theorem says that if the two angles are congruent, then these two lines cut by the transversal are parallel. Okay, let's take a look at another one. They give us angles 2 and 6. Let me erase this. So in this case, it's angles 2 and angle 6. Notice angles 2 and angle 6. These are alternate interior because they will be between these two lines, lines A and B. between these two lines, where line D now is the transversal. This line right here, this one doesn't count. So we could erase this one because this one, you know, take it out of your mind. This doesn't count. It would be just lines B and A, where these angles 2 and 6, are formed by the transversal D, and they are alternate interior angles. Therefore, what you can say is that lines A is parallel to line B. Okay, line A is parallel to line B. Again, it's the converse of the alternate interior angles theorem. Let's take a look at another one. If angle 1 plus angle 5 equals 180 degrees, which two lines? Remember, this must be what? Consecutive interior angles. Let's take a look. Let me erase what we have. And in this case, we have angles 1 right there and angles 5. Notice they are consecutive interior angles to the same lines, lines A and lines B. But this time the transversal is line C. This one down here does not count. So I am going to say, I can say that line A is parallel to line B. And that's because the converse of the consecutive interior angles theorem, or the same side interior angles theorem, says that if the two angles that are consecutive interior angles are supplementary, that means they are up to 180, that means that lines A must be parallel to line B, that the two lines are parallel. Here we go. Here's another one, angles 8 and angles 3. So I'm going to take angles 8 right here in angles 3, right there. Again, these are lines A and B, where C is the transversal. Notice that angles 3 and 8 are in the exterior, in opposite sides of the transversal. Exterior, opposite side of the transversal. So these are alternate exterior angles. So again, I can say that line A is parallel to lines B, and this because of the converse of the alternate exterior angles theorem. Let me see if there is anything else. Nope, there is nothing else. So that solves these problems right here. Okay, so now we're going to talk about flow proofs. Okay, flow proofs is another way, instead of doing a two-column proofs, we could do a proof. Okay, so for example, given angles 4 is congruent to angle 6 right here, angles 4 is congruent to angle 6, prove that lines L is parallel to line M. Well, the first statement I'm going to write is that angle 4 is congruent to angle 6, and of course that is given information, right? That is given. I could also write that angles 2 is congruent to angle 4. And reason for that is because vertical angles are congruent. Remember that theorem? Vertical angles are congruent. It's my way of abbreviating it. Then out of this, we have that if angle 6 is congruent to angle 4 and angle 4 is congruent to angle 2, then angle 2 is congruent to angle 6, right? And that's because of the transitive property of congruency. So the transitive property of congruency. I'm going to write that in there. Therefore, because the converse, right? If angles 4 is congruent to angle 6, then angles 2 is congruent to angle 6, which is what I'm saying here. And we could say, well, if corresponding angles, and that is the converse, right? The converse of the corresponding angles theorem. So angles 2, therefore, right here is congruent to angle 6, and that's what we just said. Then the lines L must be parallel to line M. So I am going to state that now, which is what I'm trying to prove, that line L is parallel to line M. And what is that reason? Well, that would be the converse of the corresponding angles theorem. There you go. And that's basically a different way to do a proof. Instead of the two-column proof that we usually do, where you have the statements and then the reasons, this is called a flow proof. Okay, so that's just another way of doing a proof. Here are other types of problems you can solve using those theorems. Also, find the degree of the missing angle that would make lines U and V parallel. Here's lines U and V crossed by the transversal. They're giving that this angle right here is 55 degrees. The question mark is, what is this angle? Well, the first thing you need to know is what type of angles are they. Notice that they are consecutive interior angles. So once you understand that they are consecutive interior angles, consecutive interior, then that means that they must be what? They must be supplementary. Notice that one is acute, one is obtuse. So they are supplementary, that means they must add up to 180 degrees. So if I take 180 and subtract the 55 degree angle that is given, then I have 10 minus 5 is 5, 7 minus 5 is 2, lower the 1. So this one right here will be 125 degrees. So because 125 plus 55, they are supplementary. So 125 is the supplement to 55 degree angle, okay? So then we're given this other one right here, where we're given this one is 97 degrees and it's asking us about this other one. These type of angles are alternate exterior angles, alternate exterior. Therefore, they must be congruent. Therefore, this must be 97 degrees. That one was easy, right? Here's what happens when we're asked to find x. These two angles that are given at 70 degrees, they are consecutive, alternate interior angles. If they're alternate interior angles, that means they must be congruent. So this one right here must measure 70 degrees. So then I could say that 9x, and I'm going to solve it right here, 9x minus 2 must equal 70 degrees. Therefore, I have that 9x is equal to 72. So remember, then I have to divide by 9, so x is equal 72 divided by 9, which is what, 8? So what is the question? Find the value of x. Well, in this case, x equals 8. That would be my answer. Okay, we have another one here where we are given 7x minus 10 for this angle and 12x for this angle. Well, what do I know? They are consecutive interior angles, or same side interior. And we know that same side interior are supplementary, so that I could say that 7x plus, or I'm sorry, minus 10. Come on, Norbert. Let's see here. Minus 10. 7x minus 10 plus 12x must equal 180. Combine like terms, that's 7x, that's 19x is equal 180 plus 10, that's 190. X equals 190 divided by 19. 190 divided by 19, I think that is 10, so x must be equal to 10. All right. Okay, here's an application problem. It says, Mr. Granda is quite a carpenter. He built this awesome white picket fence at his house, right over here. When Mr. Reyes looked at the fence, he told Mr. Granda that the pickets were not parallel. Well, Mr. Granda finds that the measurement of angle 1 right over here, let me change colors. The measurement of angle 1 right over here, it's 62 degrees. Okay, what does the measure of angle 2 needs to be for Mr. Granda to prove to Mr. Reyes the two pickets are indeed parallel? Well, angle 2, which being right over here, those are consecutive interior angles, therefore they must be supplementary. So angle 1 plus angles 2 must add up to 180. Since angles 1 measures 62 degrees, then we could take 180 minus 62 would give me the measurement of angle 2. That's what measurement of angle 2 needs to be in order for the two pickets to be parallel. That would be 10 minus 2, that's 8. 7 minus 6, that's 1. So that's 118 degrees. So the measurement of angle 2 would need to be, the measurement of angle 2 would need to be 118 degrees for those pickets to be parallel. Okay? In fact, you try these. Find the degree of the missing angle that would make lines U and B parallel. And then find the value of X that makes lines U and B parallel. You try them, pause the video, and then come back and take a look at the answer and see if you got it right. Okay, I hope you work the problem and check. Remember, these two right here are consecutive interior angles, therefore they must be supplementary. So all you have to do is subtract 121 from 180. So we have 180 minus 121. 10 minus 1, that's 9. And 7 minus 2, that would be 5. So the answer for this one would be 59 degrees, right? 59 degrees. Now try the next one. Pause the video. Make sure that you do that and let's work the problem. After that, then come right back to see the answer. Alright, what you need to know is what type of angles are they. They are corresponding angles, and corresponding angles are congruent for lines U and B to be parallel. If these two angles are congruent, then these two lines would be parallel. So therefore, I could set up the equation. I could say, well, 9x minus 1 must equal 7x plus 17. Remember that congruency means that the measurements are equal, right? So I should take 7x from both sides. So 9x minus 7x, that would be 2x minus 1 equals 17. Since I'm subtracting 1, add 1. So 2x is equal 17 plus 1 is 18. Divide by 2 on both sides, so x is equal to 9. And that would make this true. That would make these two lines U and B parallel. Already. So that's it for this lesson. Remember, the best way to get good at something is by practicing. Okay, so let's go do the practice and keep practicing. Remember, the expert in anything was once a beginner. See you in class.